Welcome students. Welcome to the first class of Prep Orbit. So this channel has been created for guiding students on quant section of CAT and other MBA and BBA entrance examinations because they have a similar pattern. Only the difficulty level is higher for CAT aspirants. So the first session I have picked up for this class is quadratic equation, since it is an important topic in algebra and you might expect 2 to 3 questions from quadratic equation in the quant section. Okay, so let's start. Okay, so the standard form of a quadratic equation looks like this: ax square plus bx plus c is equals to 0. Okay, where a, b, c are called the coefficients and we have to solve for x. So a, b, c are the coefficients. Okay, and we have to solve for x. Solve for x. Since the highest power of x in the entire equation is 2, this kind of equation is called equation with degree 2. So in this kind of equation you will get two values of x. Okay, two values of x. There are three methods of solving the quadratic equation. We'll start with the first method. Okay, for that we'll take a simple example which you might be getting in exam. So x square minus 7x plus 12, okay, that is equals to 0. We have to solve this equation to find the value of x and we will get two values of x. Okay, now if you compare this standard form with this example we have taken, our a will be 1, b is minus 7 and c is 12. Okay, now method 2 is called the middle term factor. Middle term factor. Okay, so as the name suggests, so there are three terms. This is called the first term, this is second term, and this is third term. Or second term is also called the middle term because it is in the middle. Okay, so we have to break the middle term in such a way, if I rewrite it, so x square minus b1 plus b2, suppose something like this, x plus 12. So b1 b2 actually are two coefficients. I have broken 7 into, so the product of b1 and b2 along with whatever sign b1 b2 originally has should be equals to the coefficient a into c. Product of coefficient a into c equals to product of b1 and b2. How will you find what will be the value of b1 b2? We have to factorize c in most of the cases. In our case, because a is 1, if a is a different value, suppose 2 4, then we have to take into consideration 2 also along with 12. We will take that later. Since this is the first example, we'll make it simple. So we'll factorize c. So if you factorize c, this will be 2 6 is 12, 2 3 times is 6, and 3 1 times is 1. So 12 is composed of 2 times 2 times 3. I can see that if I multiply 4 into 3, I will get 12, and that gives my b1 and b2. So this is 4 plus 3x plus 12 equals to 0. So this will be x square minus 4x minus 3x plus 12 equals to 0. Now we'll take a common for the first two terms, which is x minus 4, and if you take common 3, it will be x minus 4. Now this is also a catch. You have to select your middle terms in such a way that you should get the same common in this step. Okay, now if you take x minus 4 common for this 2, so the rest of the equation will be x minus 3, and we have got product of two factors which is equals to 0. Now if product of two numbers is 0, we can say a equals to 0 and b equals to 0. So same way, so we'll equate x minus 4 equals to 0, which gives us x equals to 4, and x minus 3 equals to 0, which gives us x equals to 3. So these are the two answers or solutions for x for this quadratic equation. In mathematical terminology, these solutions are also called the roots of the equation. Solutions of x in a quadratic equation are also called roots of the equation. Okay, roots of the equation. Okay, so our answer is 4 and 3. So this is the first method, middle term factor. There are two more methods. We'll see how we'll get the same answer with the other two methods also. Okay, and one thing, all three methods are equally good. You can use it based on the convenience or the type of questions you are getting. That will come through practice. Okay, now I'll go to the second method. Okay, the second method is called completing the squares. This is called completing the squares. Okay, so completing the squares means x square minus 7x plus 12 equals to 0. I will take these two terms and will try to see how we can use this to form a plus b or a minus b whole square. So if a minus b whole square, a square minus 2ab plus b square, we know the formula. A plus b whole square will be a square plus 2ab plus b square. Now when to take a minus b, when to take a plus b whole square, right? So if this is negative, we have to go with a minus b whole square. So x square minus, if you try to arrange it in 2ab form, so 2 into a is x, then b has to be 7 by 2 because we should arrive at the same middle term, which is 7x. So only with b as 7 by 2 you will get minus 7x, because 2 will get cancelled and 7 times x will be minus 7x. Now since 7 by 2 was not there, and but we need it as b, we have to add b square also. B is 7 by 2, but since it was not in the picture, we have to subtract that also, right? And then 12 was originally in the equation. So if you solve this again, you will arrive at again x square minus 7x plus 12x. So we have not changed anything. We have introduced something and then subtracted the same thing to keep the equation same. Now this part of the equation can be written as in the a minus b whole square form, then minus 49 by 4 plus 12. Now we can take these two terms on the other side of the equation. So x minus 7 by 2 whole square equals to 49 by 4 minus 12. If you take LCM 4, this will be 49 minus 48, this will be 1 by 4. Okay, now x minus 7 by 2 whole square we have got as 1 by 4. If you do a square root on both sides, this will be x minus 7 by 2 plus minus of half. Now you have got two equations again. This is half plus and x minus 7 by 2, which is minus half. So this is x equals to 7 plus 1 by 2, which is 4, and this is x equals to 7 minus 1 by 2, which is 3. So we got the same answers with a different method. Okay, so this is the second method, which is called completing the squares. Hope you have understood this. Now we will jump to the third method. Okay, so the third method is also called using the quadratic formula. Okay, method 3, using quadratic formula. Okay, so what is the quadratic formula? So the two roots which we mentioned in the first method is also called alpha beta, can be written as minus b plus minus, because we are trying to find alpha beta only, right? B square minus 4ac by 2a. So my b, a and c are the same coefficients which we have written here. A equals to 1, b equals to minus 7 and c equals to 12 in our case. Now if you put the value minus of minus 7, so this minus is extra and this b comprises of the sign of the b also, right? Plus minus of minus 7 square minus 4 into 1 into 12, okay, divided by 2 times 1. So this will be 7 plus minus of 49 minus 48 by 2. If you solve it further, it will be 7 plus minus root over of 49 minus 48 is 1. If you do root over of 1, it will be 1 only. So 7 plus minus of 1 by 2. So you have again two cases, 7 plus 1 by 2, which is 4, and 7 minus 1 by 2, which is 3. So these three methods are equally good. When to use when will be decided by what kind of questions you are getting, okay, and they are equally efficient and will be used from time to time. I hope you have understood this very basic methods of solving a quadratic equation. We'll see other topics of the quadratic equation in subsequent sessions as we move through the classes, and we'll try to cover all types of questions which you might encounter in CAT using some of the previous year questions.